Good afternoon, ladies and gentlemen. My name is Vladimirs Gostilo. I'm from Baltic Scientific Instruments, and the title of my today talk is Semiconductor Materials and Technologies for Nuclear Radiation Detectors. Which one? I got you. This one. Okay. So, semiconductor materials and technologies, that is a main part of core business of our company. Developing technologies, developing semiconductor detectors for registration of X-ray, gamma ray, charged particles. We design based on that these detectors different equipment which we deliver for market. Our market we earn in a nuclear industry, environmental monitoring, and non-destructive analysis in mine. And in different scientific applications, space applications, medicine, ultra-low background applications, high-energy physics, we earn our scientific reputation and confirm our scientific level. We are working because we specialize in the most precise part of spectrometric equipment. We working with high-purity germanium, silicon, cadmium zinc telluride, thallium bromide, and recently we started to work with scintillation material lanthanum bromide, cerium bromide, strontium iodide, because energy resolution of these materials already less than 3% on energy 662 kiloelectron volt, and this energy resolution allow already to solve different spectrometrical tasks in parallel with semiconductor materials. If to look at the technologies which we use for detector fabrication, now you see that is the same technologies like electron industry use for different sensors fabricating. Mechanical processing of crystals, chemical processing, diffusion, refinement, implantation, vacuum metallization. That's all these technologies are from electronic industry. But in electronic industry, working with thin substrates, we're working with very volumetric piece of semiconductors. Sometimes weight of, for example, high purity germanium crystals is up to 3 kilograms. You can imagine, so it's absolutely impossible to make any automation of mechanical processing or lapping, polishing of such big volumetric samples. So practically all this technological operation technologies do by own hands, not depending. Is it in, for example, high purity germanium detectors on a high industrial level are able to provide only 2 American companies, Canberra and Nortec, and 1 Latvian company, Baltic Scientific, not depending on where the detector fabricated, only by hands of technologists, mainly. So, and we produce a big number of different types of high purity germanium detectors. I will not load you with technical specification of the detectors. Who will be interested, I can give all these numbers. I will give you only features of some interesting types of detectors and some interesting applications. As I said, three companies in the world produce such types of germanium detectors for standard, let's say standard detectors for main part of applications. But a lot of different, very specific tasks require very special detectors, and such detectors we fabricate under special requirements of the customer. For example, here you see the most sensitive detector, which we designed and fabricated with diameter 110 millimeters. Canberra and Nortec produce such detectors with diameter up to 90 millimeters, and we also produced mainly with 90 millimeters, but for special tasks for registration of gold in ore, we designed such very sensitive high purity germanium detectors, and due to that we can provide detection limit of gold in ore on the level of 0.04 gram per ton. That is also a very specific construction of detector with inverted electrodes for measurement of very low activity of small amounts of medical materials. You can put here small amount of such medical materials, so you will provide 4P practical geometry for measurement, and due to construction of a detector, sensitivity, efficiency registration of radiation of this material will be very high. Who knows CMS detector in CERN? Looking on this picture, now you see that very similar to those detectors. That is like semiconductor analog for CMS, and principle of working is fully the same. Target you can put inside, beam goes through this hole, react with the target, results of reaction escape to different directions, and segments will show which direction you have, and in parallel each segment provides spectrometry, will give energy, will give intensity of radiation. So that is a very unique detector which was designed for investigation of nuclear reactors by us. No, you see mechanical processing of such crystals. That is semiconductor material. You can imagine how quality should be for such detector to provide high performance. That is also very special detector for orbiter. Space radiation irradiate surface of planet. This material on the surface of planet irradiates secondary radiation, and if no atmosphere, this radiation can reach your orbiter. You can collimate radiation, register with a high purity germanium detector, and provide full information about elements on the surface. Before that, it was impossible to send high purity germanium to the space, because high purity germanium working and provide the best performance only with a cooling up to temperature of liquid nitrogen. you will never send liquid nitrogen to space. At present time, no, you see here micro cooler, Stirling type micro cooler, which we used here for cooling of this detector. Power is very small, about 6 watts, but because it's enough time to go in space, it's possible slowly to cool down detector till necessary temperature. At present time, we produce a very big amount of high purity germanium detector with Stirling coolers, more powerful than this one. But any case, that was very unique prototype, which was ordered by the European Space Agency from us. Weight is about 2.9 kilogram. Power, I said, about 6 watt. So very acceptable for space applications. We also provide fabrication of high purity germanium detectors for different international projects where rare events should be registered. That is investigation of dark matter search, double beta decay registration, neutrino, anti-neutrino registration, and all these investigations require very ultra low background devices. So using very special materials, using very special technologies, we fabricate such devices for such project, and we can provide you possibility to register, for example, 1 event per day. Who are dealing with measurement understand that if no events, it's only background. 1 event is happening, how to take out this information from this event, from all this background. So we can provide such special devices for that. Now here you can see one of such devices for such applications that was fabricated for Tsinghua University for detectors, hemispherical detectors with thin entrance window was assembled in this construction. And here you see our ultra low background spectrometer in PHOTONICA-LV mines. It is the deepest mine in Europe. Depth 1 kilometer for 140 meters on the depth. That for
where is it?
Installation. Sorry,
Where is it?
PHOTONICA-LV.
Finland, which is
Finland. PHOTONICA-LV. So we fabricate such special detectors. We have special chambers to keep crystals. We have very special materials for processing of these crystals. Only no space here to show everything. We are working with silicon, also fabricating ion implanted detectors for alpha spectrometers mainly. Well, that is a very standard technology. Even I will not pay too much attention. Very specific material, cadmium zinc telluride. We're working with this material starting from 80s years of previous century, and International Atomic Energy Agency paid invested a lot of money to our team for development of crystal growth technology, crystal processing technology, and until now we are biggest producer of CZT detectors for nuclear industry. Here you see a microspectrometer with CZT detectors, but for what is more interesting for you, that this material is interesting also for imaging applications. We fabricated one of the first pixelated detectors for NASA for focal detectors, and here you see 4x4 pixel detectors, 4x4 pixel detector for Marshall Space Center, and we provided extremely high spectrometric performance, very good reproducibility from pixel to pixel on this detector, and it was 2000 at those time. At present time, we fabricated detectors with much more number of pixels. Here you see, it seems to me 32 by 32 or 64 by 60. Who can calculate? Also, here you see Kaplaner grid detector, and that is not computer, that is a photo of the detector. You can evaluate the quality of photolithography on this crystal. By the way, dimensions 20 by 20, that is very big crystal for CZT. CZT, small enough detectors, for example. Here it's 10 by 10, it seems to me. Now, assembled such detector, pixelated. Here it's 16 by 16 with such special contact system. Assembling of such detectors, that is the most big problem until now. Not difficult to pixelate crystal and provide very good performance, but the most weak technology until now, that is assembly. Well, that is my favorite application, nuclear industry. That is the tomographic system. That is slit collimator, 104 detectors is inside CZT with ASICs, electronics based on ASICs, and that is that system to control spent fuel rods directly in water ponds of nuclear power plants. Fully automated, also with powerful software. So you see that from one side we are working with technologies of detectors themselves. From another side, we produce very complicated spectrometrical systems for different applications, mainly for nuclear industry. Also, we're working with different new materials. That is the prototypes of thallium bromide detectors, with which also we developed and tested under the contract with European Space Agency. We developed a lot of detectors for this agency for different tasks of ESA, and we continue to work with these detectors until now. Performance we reach good enough, but there is only one problem with this material: no stability. Ion conductivity of these crystals do not allow to tell that we produce detectors. We produce prototypes for testing. There is one way we have found a solution how to stabilize technical performance necessary to cool these prototypes with a Peltier cooler up to -20. But that's already make equal thallium bromide with cadmium zinc telluride, where no such instability. So no so much, not so big reason to use such detectors with the cooling. No, but like the subject for investigation, this crystal is very popular. At present time, we are planning to start a project with perovskite crystals. Perovskites are widely used at present time for solar panels, but growing at very special conditions, these crystals also can be used for semiconductor detectors with a direct registration of radiation. So we will prepare a project for using of such material for detector fabrication, development of technologies, and I think also it will be interesting project. Well, all these technologies should be supported by special equipment. I said you that all technologies which we use, that is very general technologies, but only necessary to know how to use, what to use, and be careful in such fabrication. So here you can see some our facilities, etching, one of the etching working places, photolithography, two tools, two departments with vacuum deposition of metals, semiconductor materials for structure, detector structure fabrication. So everything is very general, like in all companies. Assembling in a clean room, in a glow box. I said you about difference between our products and products of electronic industry. In electronic industry, all devices are in structure of substrate and closed by dielectric from the top. So all PN junctions are inside crystal. In our volumetric detectors, all PN junctions are on the surface. That is a big problem, and that is the reason why our main enemy not dust like in nuclear, like in electronic industry, but humidity, oxygen, hydrogen, everything what can create any pollutions on the surface of PN junction. So sometimes we assemble our devices in such glow boxes with humidity less than 1% for to provide stability and long term of life of our devices. No, probably devices will be not interesting for you. That is ways to say monitors for nuclear industry, where, as I said, we earn main part of our money in nuclear industry. That is our biggest product, that is gamma activation laboratory to provide registration of gold in ore. I said you see that detection limit of gold you can evaluate. We're champion of the world in this application. And at present time, we also prepare some projects for development, fabrication already of such laboratories. That is a big facility with many devices and very saturated with different methodic for registration. Well, practically that's all. So if you have a questions, I'm ready to answer.
Thank you, Vladimir. I would like to add 2 points. I have meeting with colleagues from Singapore. I'm asking, do you know something about Latvia? No, we know nothing. Do you know that company from Latvia secured nuclear pollution security for Singapore? No, but company led by Vladimir, secured Singapore from coming in with nuclear.
Really, one of the of our products that is early warning systems for control of territories. First, our project with Singapore was we equipped military harbor with such systems, which allows them to register not only air but aquatorium, because they're very afraid that nuclear submarine are coming through strait in Singapore and even coming in harbor. And no, for sure, cooling water from nuclear reactor go outside. So after that, more project was signed, and we equipped all territory of Singapore. We installed 10 stations around territory, with which allow to control aerosols from the air, iodine, also like result of pollution from nuclear power plant, and 5 stations on the water, on the buoys, which provide registration water on the depths, and 5 stations on the piers. So really everything is surrounded by such systems.
And point 2, Vladimir and his company secured us from some nuclear disaster in Europe, because Chernobyl nuclear site was looted by these soldiers coming invaded, and also monitoring systems were damaged, and Vladimir's company restored its all by their own.
Yeah, we
from our
really restored and repaired all our spectrometers, installed in 2 laboratories in Chernobyl. We have about 15 devices there. And at present time, we are permanently in contact with all staff of nuclear power plants. Now we assist them also to study simulation software, because they have a lot of different measurements, and using a simulation at present time it's possible to have results without measurement. If you know geometry of your detector, if you know geometry of a sample which you want to test, it's very easy to make simulation of your task and do not carry out a measurement to have results. So now we already finishing with them these things, and waiting for when Zaporozhye situation will be changed.
On agenda now.